All right, Justin and Alex, let's see what we can do here. Okay, they do ask you to sketch these graphs, right? However, these are both in standard form. They're just lines. So let's first of all just find out where it hits the x-axis. Any point on the x-axis is going to have as its y-coordinate 0, right? Because it's sitting on the x-axis. So if we set y equal to 0, we just have 5x equals 20, divide both sides by 5, and x is 4. I promise you this is going to hit the x-axis at 4, 0. As far as the y-axis goes, remember slope-intercept form, y equals mx plus b. We just want to put it in slope-intercept form and we'll be able to see what the y-intercept is. So subtract x from both sides and go ahead and divide everything by 2. So we're going to get y equals, that'll be a negative 1/2 x and plus 11. It's going to hit the y-axis at 11. A is 4, B is going to be 11. Okay? All right, the lines themselves intersect at C. We could certainly graph them to get that. However, if I had put this one in slope-intercept form, I would have had y equals negative 5x plus 20. These are both in slope-intercept form, so we're just going to set, I'm going to set these two things equal to each other really quickly, again, just to solve. So if they intersect at C, let's find their solution. Negative 5x plus 20 equals negative 1/2 x plus 11. Let's just go ahead and double everything to get rid of the fraction. So negative 10x plus 40 equals negative x plus 22. I'm still going to bring the smaller one over. I'm going to add 10x. Okay, so we get that 40 equals 9x plus 22. Subtract 22 from both sides, 18 equals 9x. So x is 2. And then you go back and plug 2 in somewhere. If you plug it in right here, you're going to have negative 10 plus 20, right? You're going to get 10 for y, substituting the 2 in. So they're going to intersect each other at 2, 10. Let me go ahead and graph them though. But I know all of that before I graph them. Gave myself a whole sheet of graph paper. Sorry to take your time to do this. I should have set this up first. 2, 4, 5, 2, 4, 10, 2, 4, 15, 2, 4, we're up at 20. The problem is I'm not going to be able to get my phone high enough to zoom out, I don't think. And then over, I think it'll be okay though. All right, I'm just gonna graph those lines, okay? So the first one was hitting up at 20 with a slope of negative 5, down 5 over 1, down 5 over 1, down 5 over 1, down 5 over 1. And it should be no surprise that that is the point 4, okay? We already knew it was gonna hit the x-axis at 4, 0. But this point right there, that's A, okay? B, negative 1/2 x plus 11. So 11, down 1 over 2, down 1 over 2, down 1 over 2, and so on. Okay, so here's the second equation, and I never did graph the first one. There's the second equation. If I graph that steeper line that had the intercept up at 20, they're going to intersect each other right here, and that intersection point is C. And we already found out that C is at 210, and you can see that that is indeed where they intersect, okay? And this was point B. All right, after that, they ask us to find the area of triangle OBC, and we can use area equals half of its base times its height. So O is the origin. Here's O. All right, let me change colors. So we get that we have this triangle OBC here, and we want to find its area. Well, because I have a vertical line, let's spin that around and think of it as our horizontal. This is going to be the base of my triangle because I can see that my height H right there is 2. So this triangle has a height of 2 and a base of, that's 11 units. So the area is just going to be half of the base 11 times the height 2. And you just get 11 square units for A. Okay, now this one's a little harder to see, but if we want A, B, C, E to be a parallelogram, A was down on the axis. We know B was here. So A, B, E, C, and back down to A. It's going to look something like that, just setting it up. But remember, opposite sides are parallel and congruent in a parallelogram. So which side is running parallel to AC? BE. We know AC, and that's the only one we know. Here's segment AC. Change colors one more time. So AC, we could just kind of use the concept of slope to get there. If we go over 2 and up 10, that gives me segment AC. So from A to C was over 2 up 10. I'm going to do the same thing starting at B. I'll go over 2 and up 10, and that's going to give me the location of E. So if we go over 2, over 2, up 2, 4, 6, 8, 10, this would have to be E. All right, but mainly we just want to know what the location of E was. So E is left 2 from B. B was, at 0 for the x coordinate. So it's going to be -2 for its x coordinate. And we went up 10 from here. So this was the ordered pair 0, 11. We went up 10, so E's up here at 21. And it's a weird looking parallelogram. However, if we draw it, you can see it's just really kind of tall and skinny and stretched, but it is indeed a parallelogram. Okay? All right, that's the first question. I might not get to all of them tonight. It's been quite a week, but I'll try.